Welcome to UGC EPG Pathshala. Hello everybody. We are going to talk about today open source GIS. We are going to visualize the open source GIS, different parameters, what are they and how do they operate, and it's a reality today. We are also able to understand the nuances of open source GIS. We'll also be able to compare open source GIS software with proprietary software that are available in the market. And at the end of it, we'll be better equipped while selecting a GIS software for different projects. 10 years back, I wrote that there's a paradigm shift from proprietary software to open software. And this is quite visible today. I wrote in geospatial today. And after 10 years, that is in 2017, the open source GIS basket is much bigger and much versatile. The development of open source GIS software has, in terms of software history, a long tradition, and the first GIS open source software came way back in 1978. Though it started about 40 years back with spatial less ideological baggage than free software, it is now appealing more to the geospatial industry. We have more than 1,000 open source software which can be accessed easily today in geospatial arena worldwide. Thousands of software developers are experimenting and gearing up to shape their codes with geospatial community in a democratic way. The growth of open source software has received substantial attention in last few years. And even the adoption of open source software system in development nation as a means of reducing licensing costs and of promoting indigenous technological development by having success to the source code of the system has definitely done well. And this is what's been written in many books too. Even now, you find that FOSS4G conferences are also happening, and everywhere people are talking about open source software and different developments. What we find today that there are so many software which are already listed in the open source GIS domain. You have as many as 223 open source software which are related to GIS, which are there right in the portal. MATLAB, Linux, Archive, OSRS, so on and so forth. And even similarly, you have QGIS, GRASS, etc. UDIG are other few successful examples. By no means you can say that open source software is trying to take over the proprietary software, but definitely they are here to stay, and we are definitely going to go ahead and make use of all these software. Open source software in this lecture implies principally a software in which users are given or can obtain the original source code from which software is compiled, and also where license is incorporated that permits users to modify and redistribute the code. So the key word is code. Obviously, geospatial ethics cannot be overlooked, and at the same time, relevant acknowledgements also had to be given. So now the question is, why open source GIS has become so important today? Let's look at the open source available services alone, which everybody is talking about today. We've got so many technocrats, we've got so many civilians who are using today geospatial technology. So what I'm talking about in September 2017, I'm talking about different location-based services, which we all are using. And these all are popularly known as LBS, and they refer to the delivery of services to users or machines using real-time location data in conjunction with other contextually relevant information. There are two major trends which are driving LBS today: smartphone adoptions and quick sharing capability of hyper-local information, with a global smartphone user base expecting to reach 2.5 billion mark by 2018, and global enterprise LBS market will reach $19.8 billion by 2020. How can we again overlook open source software? There are four categories of LBS which are there. One is LBS tracking, LBS navigation, LBS infotainment analytics, recreation and fitness, and some of the prominent vendors for the LBS market, which we all know, are Apple, Here, Mesilo, and Telenow, and so on. In terms of social applications using mobile location data, or which you all are also using, the target users, are using Facebook, Twitter, Instagram, WeChat, and Weibo, and these are the top players. So that means there's so much apps are there which are transforming different platforms themselves and offering much more information, spatial data. And another big thing that's happening in the geospatial landscape, MR, AR, and VR. Till about a year back, we were finding 3D information. Now we are talking about mixed reality. We are talking about something which we referred as mixed reality. Though often used together and often used interchangeably, there is a fundamental difference between AR, VR, and MR, and all these are here to stay. And if they are here to stay, then that means open source is also here to stay. Let's understand each of these worlds. What is AR? Augmented reality. The moment we talk about that, this supplements your world with digital objects of any sort. Augmented reality headsets overlay data, 3D objects, and video into your vision in some way or another. And all this while continuing to let you see the world around you. For example, you all are using Google Glass and all that, that's something which is so very real. Then a very interesting example of AR is one of those medical center replacement project. To help field personnel quickly access 3D BI models and other project documents, general contractor McCarthy Building Companies placed hundreds of QR codes throughout the Oakland Medical Center replacement project complex. And as a result, what happened? Users simply scanned one of the OR codes with a smartphone or tablet computer and instantly immersed themselves in the up-to-date as-built 3D BIM mode or 3D laser scan of that space. And that's what is augmented, and that's what is something, augmented reality. Now let's talk about the virtual reality. Virtual reality replaces your world with a virtual one. Then that means each involved looking into the headache with lenses that look at the virtual screen. VR makes you completely immersed in another world and blocks everything else. Example, Oculus Rift, HTC Vive, PlayStation, etc., etc. What are they doing? That's what they're showing, the virtual reality of something which is so real. And these experiences can be viewed in a free ArcGIS 360 VR app that's available from the S3 Labs too. And then the third category which you have are the MR, what's called a mixed reality. Mixed reality integrates digital objects into your world, making it look as if they're really there. Mixed reality is a mix of real world and virtual world. It's somewhere between AR and VR. Example, Microsoft, in case you look at the HoloLens, Trimble, and other smart helmet integrates mixed reality applications to enable companies from architecture, engineering, construction, operations, and so on and so forth to improve team communication, data interpretation, and collaboration in their work. And together they are being hailed as the next big thing in the geospatial industry. So how can they help? In addition to this, what we find is that the city planning and engineering, these technologies could have big appeal in disaster management, real-time applications too. In case if there is an earthquake somewhere, or you have tsunami, or you have another disaster, you find that open source is a great help. And somewhere along the other, you cannot ignore today open source. So now that means we need to understand, and so now let's understand the basics of open source. I hope we all agree to the fact that open source is here to stay and it's making our life easier. So let us understand the basics of open source. For understanding the nuances of open source software, it's relevant to understand related terms. One is free software, freeware software, and proprietary software. It is general perception that the only distinction between open source and proprietary software is that one is free and the other is not, which is not true at all. Just note it, this is not true at all. Each are based on differing philosophies, methodologies, and business models. Open source software is almost by definition more flexible, but requires more effort to use, whereas the opposite is true for proprietary software in general. All open source software is required to be licensed, as shared by Maurya. It's important for us to understand that open source software are unique with open source codes. They by no means imply free software and freeware. nor free software and freeware are synonyms. Free software is opposite to proprietary software, where proprietary indicates that a party exercises private ownership control use over the item of proprietary user to the exclusion of the other parties, as Wikipedia says. That means you got a question of the ownership the moment it's proprietary, and where you have a free access, it's an open source. So then that means, it's something which is so very important, and we need to understand that open source is now being there. Proprietary software restricts users' right and protect ownership rights, as I've shared with you. ArcGIS, MapInfo are all proprietary software. When software vendors make their software available to the users, free or freedom to open is there. The freedom to open definitely changes. They are referred to as freeware. When there is a freedom to open charge, and then they are referred as freeware. While free software means freedom in users' favor of whether software is free or not. Free software can be used commercially. Remember that. They are also licensed software. GNU project establishes 4 freedoms by qualifying them as free software as promulgated by the Free Software Foundation, FSF, founded by Richard Stallman. One is a freedom 0. That's the freedom to run the program for any purpose. Second is freedom 1. The freedom to access the source code to understand how the program works and make needful adaptations. Third is freedom 2, the freedom of redistribution. And fourth is the freedom 3, the freedom to improve the program and redistribute the improvements. In February 1998, that is 20 years back, the open source group adopted open source label to free software, arguing that open source carried less ideological baggage than free software and would have greater appeal to businesses even though the software and the approach were the same, as we find in the writings of Jack Schiffel too. And this supposition has generally proved correct. So open source, in case if I go by the definition, it implies access to the source codes. Software developers are creators of human readable program statement referred to source code. And these are written in high level or assembly language, C++, Java, PHP and so on, and are opposed to object code which, though derived from the source code, are designed to be machine readable. This literal meaning of open source is necessary but not sufficient for a full definition. The mere fact of making sources code available does not make a program open source, as mentioned in one of my writing, Parihar 2007. According to the definition given by the open source organization, the organization laid criteria clarifying distribution terms of OSS, as mentioned in www.opensourcegis.org portal, on dual aspects, source code and its licenses. As for source code, the criteria prepares, number 1, the source code to be readily available in a legible format. 2, wherever some sections are amiss, its source code be made available via internet without charge. Next, the derived work be distributed on original terms of the OSS. And then, of course, integrity of the author's source code be retained, with derived work to carry different names or version numbers from the original OSS. So basically what we have seen, we've talked about the license, we've talked about the source code, and then we've talked about the ethics. A next criteria of the licenses of open source software further simplifies the redistribution and makes this software really open. So now let's spend a minute on license. License will be free, note it. It will be free, whereby requiring no royalty or fee for selling or giving away the software. A single license extended to all those whom the program is redistributed. Then the license must not be specific to product or restrict other software and be technology neutral. Moreover, there will be no discrimination against persons or group or any fields of endeavor. It's actually neutral. I mean, everybody can use it. Some examples of free licenses are, can you make a guess? I'll tell you. BSG Style, GNU General Public License, GPL, Grade License, Apache Software License, and so on. The procedure of implementing free software license is necessary to protect their users' legal rights and to ensure the freedom of the software. With open source software, the user can access the resource code and redistribute it. Let's now talk about, after understanding the relevance of resource code, redistribution, mechanism, licenses, let's now talk about the criteria for open source software. Criteria. There is misconception among users and developers about the actual meaning of open source software. As I shared with you before also, and open source doesn't just mean access to the source code. As Moreno said, he deliberated the criteria for the open source software as following. Number one, free distribution. There is no restriction on selling, no royalty, no profit from any sale. Remember, free redistribution, no restriction on selling, no royalty and no profit. Second criteria is the source code. The program must include source code and must allow distribution in source code as well as compiled form. Where some form of product is not distributed with source code, there must be a well-publicized means of obtaining the source code for no more than a reasonable reproduction cost, preferably downloading via the internet without charge. The source code must be preferred form in which a programmer would modify the program, right? Third is what we say not allowed. Deliberately obfuscated source code is not allowed. Intermediate forms such as output of a preprocessor or translator are again not allowed. Why? Because we are targeting accessibility at no cost. Then the next criteria is derived works. The license must allow modifications and derived works and must allow them to be distributed under the same term as the license of the original software. Integrity of the author's source code is also very important. The license may restrict source code from being redistributed in modified form only if the license allows the distribution of patch files with the source code for the purpose of modifying the program at build time. What I mean is that the license must explicitly permit distribution of software built from modified source code, and the license may require derived work to carry a different name or version number from the original software. I mean, version can be different, name can be different. There can be no discrimination against personal or groups. Remember, no discrimination. The license must not discriminate against any person or group of persons. It's very secular. There is no discrimination against fields of endeavor too. The license must not restrict anyone from making use of the program in a specific field of endeavor. For example, it may not restrict the program from being used in a business or from being used for a genetic research and so on and so forth. Another criteria is the distribution of license. Let's talk about that. The right attached to the program must apply to all of whom the program is redistributed without the need for execution of an additional license by those parties. That means license must not be specific to a product. What did I say? License must not be specific to a product. Second, license must not restrict other software. It's not that if I'm having this, then that should not say that I should not be able to use another. Okay? The third is license must be technology neutral. There is no provision of the license may be predicated on any individual technology or style of interface. All right? That's why it's so important. So after understanding the codes and the licenses, let's talk about now open source software, different software. They play an important role, which we know by now. We also have understood about the license. The procedure of implementing free software license is necessary to protect their users' legal rights and to ensure the freedom of the software. There are several organizations that can provide free software license, like GPL, General Public License, Lesser General Public License, LGPL, and Berkeley Software Distribution, BSD, and so on and so forth. There are different open source software which are available today, open source desk GIS software. I'll just name few of them because of the less time. Stinger and Boscher in 2008 had studied these software and have called them as good software. Let me just name them. One is GRASS GIS, originally developed by the US Army Corps of Engineers, open source as Complete GIS. Second is Saga GIS, that is System for Automated Geoscientific Analysis Hybrid GIS software. Saga has a unique application programming interface and a fast growing set of geoscientific methods bundled as exchangeable modules libraries. Then we have the Quantum GIS. QGIS is an open source GIS that runs on Linux, US, Mac OS and Windows 2. The best part is it runs on Windows 2. Map Window GIS, then we have free open source GIS, desktop applications and programming component. Then we have ILWIS also, Integrated Land and Water Information System, integrate imaging and vector and thematic data. It became free, it became open, and then again it became proprietary and so on. Then we have JUMP GIS, OpenJump, Open Java Unified Mapping Platform, and the desktop GIS, OpenJump, SkyJump, DareJump, Cosmo emerged from JUMP and so on. And the table is available in the lecture which talks about all different software. Today we are going to talk about, and so that's something which I want to tell you, it's so important. So you can read the lecture which is written in the textual form for detailed list of open source software. Another thing that I want to talk about today in 2017, if I'm talking with you, today we are talking about big data, we're talking about geoanalytics, we're talking about data analytics, and the 10 open source ETL tools presented by TechRoba and just in December 2015 are as follows. So that means I'm going to talk about now open source ETL tools. What is ETL? Any guesses? Extraction, transformation and loading. That means it extracts data from homogeneous or heterogeneous data sources, transform the data for storing it in proper format, a structure for querying and analysis purposes, load it into the final target database, more specifically operationalized data, store data or data warehouse, and so on and so forth. Usually in ETL tools, all the three phases execute in parallel since the data extraction takes time. So while the data is being pulled, another transformation process executes, processing the already received data and prepare the data for loading, and as soon as there is some data ready to be loaded into the target, the data loading kicks off without waiting for the completion of the previous phases. That's what, if you remember your first lesson of GIS, today you're into your 7th lesson. I talked about CSTART, and similarly out here. So that means you read your one system is capturing data, another one is storing, another one is transforming, other one is displaying. All these are happening together because today we've got used to real-time geospatial use of data so that we can get a deliverable immediately. So now let's talk about 10 open source ETL tools which are readily available. One is Talend Open Source Data Integrator. It's a multiple solution for data integration. Both open source and commercialized editions are there. Second is the Scriptella. Scriptella is largely used or known for simplicity and for script execution tool written in Java, and one example which you all are familiar with, SQL. Third is Kettle, K-E-T-L, is a premier open source ETL tool, and the data integration platform is built with portable Java based architecture and open XML based configuration and job language. Fourth is your Jaspersoft ETL. It's easy to deploy and it outperforms many proprietary ETL software. It's giving a tough competition. Then you have GeoKettle. GeoKettle is a powerful metadata driven spatial ETL tool dedicated to the integration of different spatial data sources for building and updating a geospatial data warehouses. Then you have Clover ETL. The Clover ETL open source engine can be embedded in any application, commercialized one or otherwise. Then you have HPCC system. HPCC system is another open source platform for big data analysis with a data refinery engine called Thor. And Thor clean, link, transform and analyze big data using engine Roxy. Then you have GDocs, is an open source BI solution for the performance management, including planning, analysis, reporting, and ETL, and so on. The 10th one is Apatar. Apatar is an open source extract, transform, and load project. And this list is compiled by, as I shared in the beginning also, by TechRoba, but we also all agree to it. And I want you to remember these. So that means to say today that I do not have money or I am not using it, I do not have an access is wrong. Today they're there. It's just that you need to have a will to use it. So now, after understanding what is open source, after understanding different tools also, let's talk about strengths and weaknesses of open source GIS software. Open source GIS software have several facilities for the users and the developers. One of the foremost is accessibility. It's easy to start with. If you are starting a small company, private venture or anything, you can freely experiment through this, right? Accessibility. After accessibility is another A called acceptability. Today you have a community support to it. People are agreeing to it. People are accepting it. And people are, getting solutions also in professional forums which are there within 24 hours in case if any issue arises. Another advantage is the scalability. You are using open source software today, you can switch over to a more powerful server or add a second server behind a load balancer. Scalability is possible. Then another advantage is easy to port. When your data is kept in open formats, translating from one data type to another is straightforward. There's probably a piece of software that does exactly that, figuring out closed format. It's truly embarrassing experience and enhances control. Open source software allow extensive configurability, which means that you can fine tune the product to your exact needs. Isn't it so good? And nobody's going to tell you that just don't do this. Another advantage is that it attracts better developers. Yes, it attracts better developers. Open source software developers seem to be better performing, be more independent, productive, and curious than developers under proprietary software. Another advantage is the great web tools. There is a plethora of the web-oriented open source tools, mapping tiles, databases, web servers, web frameworks, and web authoring tools, building, which are available today. So that means open source has so many advantages. Of course, you should all try your hand to it. But again, let's compare now. In case if that's there, then why are there so many proprietary software? The billion-dollar software companies are creating profits. Let's compare proprietary software versus open source software. Today, we have many open source GIS software. They're available. QGIS is one of those which is very popular today. ArcGIS is another most popular proprietary software on another hand. Generally, what you find is that most of the big offices, most of the big companies are having ArcGIS. And so now in case if I compare these two, I have done this exercise through both of these. Number one is too many projects. There are many open source projects for every niche, and you will have to depend sometime picking the best one because others will be abundant. Second is, if I compare, is the graphical user interface. This is probably because software developers are familiar with command line tools and there are not enough open source GUI designers. The resulting GUI is often slow, ugly like Grass GIS and have counterintuitive interface. ArcGIS has excellent GUI in compared to any open source software. So that means that's the reason why people prefer proprietary software. User platforms, in case if I talk about that, most of the users and many developers will consider that as an advantage. Windows open source software tools have gone a long way in the past years, but the best of the breed software is almost always in the Linux world. ArcGIS is MS Window based software. Then you talk about the documentation. Documentation is superb in ArcGIS. QGIS has lots of documentation, well written. There are numerous tutorials you can download. It's trying, right? But it's still not at par with the proprietary. In case of talk about the supporting system, if you're going to pay for it, you'll probably get good telephone support from the vendor, whereas in open source, probably no tech support or SLA unless you pay a consultant. Talking about the cost, with proprietary software, when you need an extra software component that would fit to your existing infrastructure or need, it's probably going to cost you a lot more than the open source. But the moment I think of the effort, open source software is almost by definition more flexible but require more effort. Definitely it requires more effort to use, whereas the opposite is the true for proprietary software in general. Let's talk about the performance. QGIS is somehow faster than ArcGIS for most operational, considering QuickGIS, new architecture and code base. It's not difficult to understand why it's faster, because again, it's often difficult to improve performance of a large code base application without using new technologies. QGIS is much faster working with PostGIS than ArcGIS, unless you opt out and store your data in PostgreSQL using S3's own spatial format. Then availability of tools. QGIS does have less available operations and algorithms than ArcGIS, mainly if you consider advanced ArcGIS extension like 3D Analyst, Geostatistical and Network, that is QGIS, just support Dijkstra's algorithm for solving network problems, while ArcGIS extends it and solves more network problems. Coming to the license, this is a huge advantage that open source software can be licensed and can be distributed, whereas proprietary software can't be distributed. Another is the completeness. ArcGIS is a set of products that obviously work very well together. QGIS was born to work with PostGIS. There is also a set of products similar to S3's that pack QGIS as a desktop component. Then operating system dependency. Although open source software tools have gone a long way with Windows in the past years, but the best of breed software is almost always in the Linux world, as shared by Miguel Lacio. And in case we talk about experimentally prove it's for the case study, in case we go by that, I will definitely say that both of them have some pluses and some minuses. Either you can use them together, or you can use them as different tools. Open source is definitely here to stay and is very useful. The idea that proprietary and open source solutions are polar opposite is certainly not true. We have to understand the plus and minus of both. Software vendors have built proprietary solutions that they have later realized to be released to the open source. On the other hand, there are distributors of licenses free open source packages who also offer a for-profit license and proprietary versions built upon the original open source platform. That means they have overlapped, or they're changing, or their format. It's really difficult to decide whether qualifications, which model is the best software development model for your organization to adopt, open source or proprietary, is something which you need to talk about and you need to work about that. So in case if I say what to do and what not to do, what is very important for us to remember that we have learned today largely three things. Number one, open source software is here to stay. Number two, there's a thin line between open source software and proprietary source software in case if it comes to use. But cost, free distribution, sharing, redistribution are all those reasons why we should go in for an open source software. So just remember, open source software is not limited to just simply code sharing. It's much more than that. please use open source software, and I am totally for it. Thank you.